Hello students, this is lecture 15 and today we will solve some examples on sampling distribution. So let's start. Let's take first example. Let x1 and x2 be two independent normal 0 1 variates. Right, x1 and x2 and x2 be in two independent normal 0 1 variates. Then obtain the distribution of or show that y1 is equals to x1 plus x2 bracket square divided by 2 and y2 equals to x1 minus x2 bracket square divided by 2 are independent chi-square variates. Independent chi-square variates with 1 degrees of freedom each. 1 degree. Let's see the solution. Very simple. What is the definition of chi-square? If xi's are standard normal, then its square is chi-square distribution. So here it is x1 was normal 0 1. X2 also normal. We have to find out the distribution of x1 plus x2 bracket square. So that first of all find out x1 plus x2 probability distribution. Additive property x1 plus x2 follows normal. Additive property is if x1 follows normal mu1 sigma 1 square and x2 follows normal mu2 sigma 2 square, then x1 plus x2 follows normal mu1 plus mu2, that is 0, and sigma 1 square plus sigma 2 square. This one. And x1 minus x2 will be normal mu1 minus mu2, that is 0, and sigma 1 square plus sigma 2 square, that is. Now make this standardize. X1 plus x2 minus 0 divided by under root of 2. This follows normal minus x2 minus its expectation 0 divided by standard deviation under root 2. This follows normal 0 comma 1. And standard normal square is chi-square. So if you take the square of this x1 plus x2 bracket square divided by 2 and x1 minus x2 bracket square by 2 follows chi-square with 1 degree. हेच आपल्याला या ठिकाणी प्रूव्ह करायचं होतं. y1 is equal to x1 plus x2 bracket square upon 2 आणि y2 is equal to x1 minus x2 bracket square upon 2 याचं डिस्ट्रीब्युशन i² 1 आपल्याला प्रूव्ह करायचं होतं. That's we have proved it. Let's see the next example. Let xi is let x1 x2 up to the IID normal 0 1 variant periods. Obtain the probability distribution of u is equal to x1 square plus x2 square plus x3 square divided by x4 square x square. Okay. Here since xi follows normal 0 comma 1 chi square plus chi square with, therefore x1 square plus x2 square plus x3 square follows chi square 3 by additive property. X4 square square, its distribution is chi square 3. And here if you observe, this is the ratio of 2 chi square. And we have seen the definition of F distribution. If you divide this chi square varied by its corresponding degrees of freedom, then it will be F. या ठिकाणी न्यूमरेटर काय स्क्वेअर 3 आलेला आहे आणि डिनॉमिनेटर सुद्धा स्क्वेअर 3 आलेला आहे. जर तुम्ही त्याला करस्पॉन्डिंग डिग्रीज ऑफ फ्रीडमने जे वरच्याला न्यूमरेटरला 3 ने डिवाइड केलं, डिनॉमिनेटरला देखील 3 ने डिवाइड केलं, then you will get the F distribution. So U is equals to divided by x4 square plus x5 divided by 3 by definition of F distribution. By definition of this follows F with comma 3. आपल्याला याचं डिस्ट्रीब्युशन काढायचं होतं का? नाही. So this 3 will be get cancelled. Lies square plus x2 square plus F with implies म्हणण्यापेक्षा write it as that is. That's it. This way we have to solve. Let's see the next one. Let's see one example based on MGF. Mxt is given 1 minus 2t raised to minus 8. Identify the distribution. And hence obtain mean and variance. Its mean and clearly you can compare this with the MGF of chi-square distribution. If x follows chi-square with n, its MGF is 1 minus 2t raised to minus n upon 2. So compare with the given MGF. So by comparing with given MGF, we get mx of t is 1 minus 2t raised to 8. By comparing, we get n upon 2 is equals to 8. This implies n is 16. Therefore, x follows I square with 16 degrees. Its mean is n, which is equals to 16. Its variance is 2n into 16. Let's see some more examples. Let exercise the IID normal 0 1 find probability of summation xi square less than 65.227. How to solve this? Xi follows normal 0. Summation xi square, let y is equals to summation xi square this follows chi square with 16. Okay, so by making standardization, you can solve this. Take the expectation of y is 60, variance of y n 60 120. Probability of summation xi square is then 65.227. Probability of summation xi square, this is y, and y is chi square 60. Y less than 65.227. This probability of chi square 60 is than this. After standardizing this, will be z less than minus 60 divided by under root of this is probability of z less than is 5.227 divided by square root of 120. Let's do this. Square root of 120. 19 point this 5.227 divided by that 5 point divided by 0.477, that is 0.48 approximately. This is probability of Z less than 0.47. Now how to see this this is the this is standard normal. त्या ठिकाणी तुम्हाला काय स्क्वेअरची प्रोबॅबिलिटी कशी पाहिजे ते सांगायचं. नो प्रॉब्लेम, वी विल टेक one more example, another example for that. This probability is very simple. Z less than standard normal distribution 0.47 is somewhere here. Is nothing but 1 minus probability of Z 0.4. As because for standard normal distribution also probabilities are available from greater than 0. एवढ्या इथून पुढच्या व्हॅल्यूसाठीचे probabilities अवेलेबल आहेत. ठीक आहे. ही probability स्टॅटिस्टिकल टेबलमध्ये कशी बघायची? नॉर्मल साठी बघा 0.47, 0.4 is this and 7 which corresponding value 31918, 0.31918. Solve करा, solving you will get the okay. मग हे रेग्युलर एक्झाम्पल आणि फिशर अप्रॉक्सिमेशनचं एक्झाम्पल या दोघांमध्ये नेमका काय फरक आहे? फिशर अप्रॉक्सिमेशन केव्हा वापरायचं आणि रेग्युलर एक्झाम्पल केव्हा वापरायचं? फिशर अप्रॉक्सिमेशन ज्या वेळेस एन इफ एन इज व्हेरी लार्ज, जनरली काय स्क्वेअरच्या व्हॅल्यू जर तुम्ही ऑब्झर्व केल्या, आता या ठिकाणी हा काय स्क्वेअर काय होता 60 आहे. ठीक आहे. स्टॅटिस्टिकल टेबलमध्ये जर ऑब्झर्व केलं तर काय स्क्वेअरच्या व्हॅल्यू ज्या आहेत, दिस इज द टी, एन इज इक्वल टू 70 पर्यंत अवेलेबल आहे. त्यानंतर मात्र या ठिकाणी पहा, फॉर ऑड व्हॅल्यूज ऑफ एन बिटवीन 30 अँड 70 द मीन ऑफ tabular values may be taken. For larger values of n, this expression ठीक आहे is used. यालाच आपण फिशर अप्रॉक्सिमेशन म्हणतो. फॉर लार्ज n, जनरली n is greater than 70. ठीक आहे. त्या तसंही आपण एक एक्झाम्पल बघूया फिशर अप्रॉक्सिमेशन. लेट्स टेक वन एक्झाम्पल ऑफ फिशर अप्रॉक्सिमेशन. Example number 4. Example 5. If x1, x2, x113 are IID standard normal variates, calculate probability of summation xi square I equals to 1 to 113 less than or equals to 120 8. Now solve the example. By additive property,